Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to dear MBBS to Wuhan Medical College, Saudi. Our today's topic is buffers. Definition. Definition of buffers. Buffers are compounds or mixtures of compounds that by their presence in the solution resist changes in the pH upon the addition of small quantities of acid or alkali. So small quantities of acids or alkalis were needed for proper functioning of the buffers. The necessity of a buffer system. Buffer systems क्यों जरूरी है, क्यों necessary है? Sometimes it is necessary that a solution of a definite pH be prepared and stored. The preservation of such a solution is even more difficult than its preparation. Preparation आसान है, लेकिन इसको preserve करना जरूरी होता है, and that is a difficult job. If solution comes in contact with air, it will absorb carbon dioxide and becomes acidic. On the other hand, if solution is stored in a glass bottle, जैसे कि आप देखते हैं कि सारे solution glass containers में होते हैं, labs में, so the alkaline impurities from the glass may alter its pH. Due to these reasons, pharmaceutical solutions are buffered as the buffer solutions are capable of maintaining pH at some fairly constant value when even small amounts of acid or base are added. Types of buffers. Generally, they are of two types: acidic buffers and basic buffers. From your previous knowledge or classes, and even your first or the second class on acids and bases, you might be knowing about acids and bases. Acidic buffers. An acidic buffer is a combination of weak acid and its salt with a strong base. And you know what is a weak acid and a strong acid, and what is a weak base and a strong base. From your previous lecture on acids and bases, you know that weak acid dissociates partially, while strong acids, they dissociate completely. And so are the weak and strong bases. So weak acid and its salt with strong base. Examples of acidic buffers are examples: carbonic acid, sodium bicarbonate. This is sodium bicarbonate. Another one is phosphoric acid, and sodium phosphoric acid, sodium dihydrogen phosphate, formic acid, sodium format. Okay. So we go to next slides. The basic buffers. The basic buffer is a combination of weak base and its salt with a strong acid. Weak base and its salt with strong acid. Here is an example of weak base. The weak base, this is a salt. When this weak base reacts with a strong acid, for example, HCl, it forms a salt. It is a salt of this weak base with a strong acid. Similarly, the weak base with the salt with a strong acid. Again, a weak base and salt with a strong acid. So, acidic buffer, must be having a weak acid with a strong base. In the basic buffers, they are the buffers which is combination of weak base and its salt with a strong acid. Phosphate buffers, they are also known as the double salt buffers. Besides the two general types of buffers, acidic and basic, the third appears to exist. This is buffer system. This buffer system composed of two salts. One is monobasic potassium phosphate, monobasic potassium phosphate, dibasic potassium phosphate. Okay, this is potassium dihydrogen phosphate. This one is dipotassium phosphate. So we go to next slide. And biological systems, they are the systems in living organisms. The pH of blood is maintained at about 7.4 by 2 buffer systems. They are primary buffers. These are present in plasma. The plasma contains carbonic acid, carbonate, and acid alkali sodium salt of phosphoric acid. The other one is, they are the secondary buffers. They are present in erythrocytes, which are oxyhemoglobin, hemoglobin, and acid alkali potassium salts of phosphoric acid. Buffer action. The resistance of a buffer solution to a change in pH is known as the buffer action. So you know from the definition that buffers are the solutions that resist a change in the pH of a solution with small amounts of acids or bases are adequate. So the process is the buffer action. So the mechanism of action of acidic buffers. how the process of acidic buffering proceeds. So, a buffer system which consists of weak electrolyte and this strong uh, base, a strong electrolyte. There will be a large concentration of sodium ions or the ions and undissociated, these are the molecules. When an acid is added, if a strong acid is added, and this combination of weak acid and the strong base, this salt is formed, the changes that will occur, they are represented as, this is this salt, and it dissociates with its components, and here this a small amount of this HCl is added, this compound is formed. So this is the salt, this is a weak acid, acetic acid, sodium acetate, this is sodium acetate, a reversible reaction, forming sodium and acetate ions. When HCl is added into this solution, it dissociates into chloride and hydrogen ions. The hydrogen ions again combine with this acetate ion and forming acetic acid, which have no effect on the net pH of the solution. क्योंकि acetic acid already solution में मौजूद है. Okay? The hydrogen ion used by HCl are quickly removed as unionized acetic acid, and hydrogen ion concentration is therefore only slightly affected because acetic acid produced is very weak as compared to HCl. So the effect of HCl addition is neutralized by this buffer, and the pH is not changed. Okay. Another example, if a base is added to that buffer, if a strong base, sodium hydroxide is added to acetic acid and sodium acetate buffer, the changes that will occur, they are in acetic acid, it is dissociated into acetate and hydrogen ions. When a strong base is added, NaOH is a strong base, that means it dissociates completely. So it dissociates from sodium and OH ions. So the OH and H combine, they form H2O. Here this is H2O. So by the addition of NaOH with a strong base, there is no net effect on the pH of the solution. The hydroxyl ions yielded by NaOH are therefore removed as water. और आपको पता है, and you know, water is already present in the solution. So there is no net effect on the pH of the solution. So this is the buffer action. The supply of hydrogen ions needed for this purpose being constantly provided by the dissociation of acetic acid of this acetic acid. Hydrogen ions are formed. When more hydrogen ions are formed, the solution must be acidic. लेकिन to decrease the effect of these H ions, NaOH gives OH, hydroxyl ions. So this OH and H combine and forms water molecules. Okay. So mechanism of action of basic buffer. Consider a buffer system of NH4OH, ammonium hydroxide, and NH4Cl, ammonium chloride. So this is the action of basic buffers, and you know from the definition, basic buffers are weak bases combining with strong acid. So there will be a large concentration of NH4 ions, and chloride ions, and undissociated NH4OH molecules. Undissociated इसलिए क्योंकि ये एक weak base है, and the weak base is dissociate partially. तो इस solution में NH4OH molecules भी होंगे. When an acid is added, the strong acid HCl is added, this HCl and NH4OH and NH4Cl buffer, the changes they will be as follows. NH4OH is a weak base. It is dissociated in NH4 and OH. Okay. And when HCl is added, the strong acid dissociates completely the chloride and hydrogen ions. When hydrogen ion is formed, it is combined quickly with the hydroxyl ions, and water is formed. Here P is missing, it's H2O. The hydrogen ion yielded by the HCl or therefore yielded by this HCl or therefore removed as water. The supply of hydroxyl ions needed for this is constantly provided by the ammonium hydroxide. Solution में ammonium hydroxide है, ठीक है? It provides hydroxyl ions. जब इस solution में HCl डालते हैं, that is completely dissociated. Hydrogen is produced. जब hydrogen ज़्यादा होगी तो the solution will become acidic. लेकिन this solution is a buffer solution and it resists increase and H ions. और ये कैसे होता है कि H ions they are combined with the OH ions which are produced by NH4OH. So the effect of H increase is suppressed or decreased by the hydroxyl ions which are provided by this ammonium hydroxide. Okay. So the hydrogen ions, these hydrogen ions, they are yielded by HCl. We know from the previous discussion that when small amounts of acids or bases are added, The buffer solution, they resist changes in the pH. So this buffer solution में this solution उसमें हमने HCl ऐड किया. HCl ऐड करने से होना ये चाहिए कि एसिडिटी ज़्यादा हो जाए या pH वैल्यू कम हो जाए, and the lower pH value is more acidic. ठीक है, तो इस असर को डिक्रीज करने के लिए hydroxide ions are produced by this weak base and water is formed. और आपको पता है कि water is already present in the solution, so there is no net effect on the concentration of hydrogen ions or the value of pH. Okay? When a base is added, if a strong base is added in this very solution, the changes that will occur, the strong base है, पहले हमने एसिड ऐड किया था, ठीक है, और एसिड आपको पता है जो स्ट्रॉन्ग होता है और डिसोसिएट होता है completely, और इसी तरह a strong base also dissociates completely in aqueous or water solution. Okay? And this is a, what is this? The salt. ठीक है, the salt is formed by NH4OH combining with NaOH. So chloride and ammonia ions are produced. To decrease the effect of OH ions, NH4 is combined with OH and NH4OH is produced. And you know that it is already present in this buffer solution. So the net effect of OH is neutralized and the pH remains the same. E1 with a small amount of this NaOH is added into this buffer solution. Okay, the hydroxyl ions yielded by the NaOH are therefore, these are hydroxyl ions, they are yielded by this NaOH, they are removed as unionized ammonium hydroxide and the pH of the solution is only slightly affected. Okay, so we go to the next slide. So phosphate buffers, how they act. And KH2PO4, K2HPO4, mono and di basic phosphate buffers. This molecule, phosphate molecule, serves as a weak acid, and this molecule serves as a conjugate base. When hydrogen ions are added, this is the hydronium ion. Into this reaction, H2PO4 is formed and water is formed. So when hydroxyl ions are added to this buffer, the following reactions they take place. H2PO4 plus OH, HPO4 plus water. Water is formed and the net effect of addition of acid is neutralized. The buffer equation, that is the Henderson-Hazelbalch equation. For acid buffers, the pH of acid buffer can be calculated from the dissociation constant. Dissociation constant that is Ka of the weak acid. Ka is the dissociation constant. A is for acid. And the concentration of the acid and salt used. The dissociation expression of weak acid can be represented as, so this is the mathematics, okay? Ha is a weak acid. When it dissociates into hydrogen, anion, cation, and anion, okay? So Ka, dissociation constant of the acid. It is represented by the concentration of H and A minus over Ha. This symbol shows this represents the concentration. So the symbol for concentration. Okay. Or simplifying, H plus is equal to K over Ha over A. The simple mathematics you might be already knowing. A weak acid is only slightly dissociated. You know that well. Weak acids partially dissociate hotel. And its dissociation is further depressed by the addition of the salt Xa, which provides a ion, it is the common ion effect. Common ion effect यह होता है कि एक प्रोडक्ट या एक सॉल्ट एक ion प्रोवाइड करता है और कोई दूसरा सॉल्ट या प्रोडक्ट भी वही आयन प्रोड्यूस करें तो ये आयन दोनों में कॉमन होगा. So that is the common ion effect. As a result, the equilibrium concentration of the unionized acid is nearly equal to the initial concentration of the acid. The equilibrium concentration of A is assumed to be equal to the initial concentration of the salt added since it is completely dissociated. Therefore, in the above definition, the previous one, we represent concentration of A by salt concentration. H is equal to Ka, concentration of the acid over the concentration of the salt. So taking log on both sides, that is the logarithm, log mathematics. So log on this side, log on this side, log H, log Ka. This multiplication is converted into addition in logarithm, plus log acid over salt. Simplifying, multiply both sides by negative sign, these both sides by negative sign, so we get minus log H is equal to minus log Ka. Multiplication होगी of acid or salt is, you know from your knowledge of the pH, minus log H is equal to pH and minus log Ka is equal to pKa. So pH is equal to pKa minus log acid or salt, or pH is equal to pKa plus log salt over acid. So this is the Henderson-Hazelball equation, which helps in calculating the pH value of both the solution and the concentration of acid is there of the salt or known. So you can calculate the pH of a buffer solution. Okay. Here we go to the next slide. For basic buffers, the buffer equation for basic buffer can be calculated in the same way as for acidic buffers. So consider a basic buffer which is composed of a mixture of weak base, because basic buffers, they will have weak base and a strong acid. And its salt Ba, this salt is formed as a result of the action of weak base with the strong acid. So the dissociation constant for base can be written as BOH base. Okay, B and OH hydroxyl ions. KB, K stands for dissociation constant. B, so here the B is for the base. So it's KB is equal to B, concentration of the B, and to concentration of the OH, or BOH, or OH is equal to KB, BOH, or B. So a weak base is only slightly dissociated, and its dissociation is further depressed by the addition of the salt Ba, which provides V plus ions. Here there is also common ion effect. As a result, the equilibrium concentration of the unionized base is nearly equal to the initial concentration of the base. Equilibrium concentration of base is assumed to be equal to the initial concentration of the salt added, since it is completely dissociated. Therefore, in this equation, we represent the concentration of B plus by salt concentration. So hydroxyl ions is equal to dissociation constant of base into base over salt. So again, taking log on both sides of this equation, so log OH is equal to log KB plus log base over salt. So again, we multiply both sides by negative sign. This is the logarithm. You might be knowing it well. Minus log OH is equal to minus log KB minus log base over salt. Further simplifying it is minus log OH is equal to POH. जैसे तो पहले हमने पढ़ा था या देखा था, तो minus log H is equal to PH. So similarly, minus log OH is equal to POH, and minus log KB is equal to PKB. So POH is equal to PKB. Again, there is simplification. Minus log base over salt, or finally POH is equal to PKB plus log salt over base. Significance. So what is the significance of this equation? It's that the pH of a buffer solution can be calculated from the initial concentrations of weak acid and the salt provided when Ka is given. Dissociation constant of acid is given. How much the acid is dissociated. However, the equation for a basic buffer will give POH, and so pH can be calculated as pKW. So the dissociation constant W is for water. It will be pH plus pOH, or when simplifying, pH is equal to pKW minus pOH. pH is equal to this pKW is equal to 14. My calculations minus pOH. So the dissociation constant of a acid, weak acid, it is the pKa, or a weak base, pKb, can be calculated by measuring the pH of a buffer solution containing equimolar concentrations of the acid or base and salt. So the applications of buffers and the practical life. Pharmaceutical systems, they are used in the field of pharmacy as ingredients and most of the pharmaceutical formulations in order to adjust the pH of the product to that required for maximum stability. pH को maintain करने के लिए buffers are needed in pharmacy or the pharmaceutical products solutions. Okay, so the pH is altered, the efficacy of their product will be altered or affected. So to maintain a proper pH, buffer solutions are needed. And parenteral preparations, there are the injections. They are the preparations which are given in the form of injections. Okay, enteral preparations, they are taken by mouth, and parenteral preparations, they are given in the form of injections. So in case of parenteral preparations, pH should be considered carefully, as large deviations of pH may lead to serious consequences. इनके लिए proper pH की जरूरत होती है. If the pH is altered, or acidity is increased, it will harm our body. The ideal pH of a parenteral product is 7.4. It is the neutral pH, normal body pH, or the pH of the water, which is pH of blood. The most commonly used buffers in parenteral products injections are, these are the buffers: acetate, phosphate, citrate, and glutamate. Cell preparation, they are also pharmaceutical or pharmacological preparations, and buffers are needed to maintain a proper pH of the solution. They are used in ophthalmic preparations to maintain the pH within the physiological pH range of lacrimal fluid. That is the eye fluid. Lacrimal fluid has a pH in range of 7 to 8, but has good buffering capacity and can tolerate preparations having pH values between 3.5 and 10.5 with little discomfort. Outside this range, increased lacrimation may occur with other complications. So the buffering agents most commonly used in ophthalmic preparations, they are borate, bicarbonate, and phosphates. Ointments and creams, they are used locally. They are also known as topical products. Topical products which are used on skin, such as ointments and creams, they are also buffered to ensure stability of the formulation. The most commonly used buffers and ointments Ion means they are citric acid, its salts, and phosphoric acid and its salts. Thank you. It was all about the buffers. So you should go through your books and go to a complete detail of the concepts. Thank you.